Hello, um, this is Dr. Ihachi. In this video, I am explaining the process of naming bicyclic alkanes in organic chem. It's one of the disturbing nomenclature problems. So what is a bicyclic structure? Bi means two, cyclic comes from the word circle or a ring. So let's say, for example, you have this structure right here. This is termed as bicyclic because you have a ring on the left or a ring down and a ring up, whichever you look at it. So the very first step is to identify the bridging carbons or the bridge heads, which happens to be the connecting carbons. Those two are the bridge heads. We call them the bridge heads. Okay, and then start numbering from the bridge heads, which is the bridging carbons, so to say. So you could either start numbering from there or from here. Let me assume I'm numbering from the back there, from the back side there. So I would go 1, 2, 3, 4, 5, and I'm going this way because you want to go through the sides with more carbons than the next side with the least carbons. So 5, see, this side has more carbons because you have 1, 2, 3 carbons here. Here, if you cut the ring, you have 1 and 2 carbons. So this is 3 C, this is 2 C, and then of course if you cut this side, that's only 1 C. So I'll go with the side with more carbons, not counting the bridgehead carbons. So I'm going 1, 2, 3, 4, 5, 6, 7, and this top one will be 8. Okay, so I'm going 1 up to 8. Now remember again, this side has 3 carbons exposed, this side has, cutting these bonds, has 2 carbons exposed, and the top one has only 1 carbon exposed. But overall I have 8 carbons, so which means that the total number of carbons making the bicyclic structure, going with point number 4, excluding the carbons of the substituents, are 8. Total are 8. So this guy has to be an octane. I don't have any substituent. Okay, so the name of this compound will be bicyclo. Writing in this format, it will be bicyclo, and then brackets 3 dot 2 dot 1. So that's my ABC. Okay, and then the total number of carbons is 8 octane. So that structure will be bicyclo 3, 2, 1 octane, where 3, 2, and 1 are the number of carbons exposed per each side of the bicyclic structure, listing it in decreasing. You're listing those A, B, and C in decreasing order of value. Let's do another one. So now let's say that you have this bicyclic structure. This guy right here. How would we number this? Again, I identify my bridgehead carbons. There's no substituent, so I'll look and say this side I have 1, 2, 3, 4 carbons on this side. On top here I have 2 carbons, and on these other sides I have 2 carbons. So I would rather prioritize the side with the more carbons, so I can start from here 1, 2, 3, 4, 5, 6, and then I see I have 2C. I could go up on the other side. Let me just maintain the bottom part. 7, 8, then 9 and 10. So overall this has 10 total carbons, so I'll call that a decane. Okay, there's no substituent. Again, I have a 2C, 2C, 4C per side. So in my brackets, I'll have 4.2.2. And then, of course, I'll have to start with the name bicyclo, with the prefix bicyclo, 4, 2, 2, close the brackets. Then overall total number of carbons making the bicyclic structure is decane. Sometimes we do have substituents. In the structure. So we would have to take care of the substituent. So let's say that's my substituent right there. So in this example C, I will identify again my bridgehead carbons, the carbons that are connecting the bicyclic structure. I have two ways. I could either, so you see this is a 2C, this side is a 2C, this side is a 2C, cutting the bond, and then this is a 1C. So I could either go 1, let me find a different color here. I could either go 1, 2, 3, 4, prioritizing the side with the longest carbons on the side, and then 5, 6, and then this top carbon will be 7. That's one way. I could number it in white. I could also number it like this: 1, 2, 3, 4, 5, and 6, and then 7 on top. And there's another way where you could avoid going through the chlorine, but that would be wrong, because when you have a substituent and you have a tie on each side, which goes with rule number 3, where there's a tie, go with the side with the substituent to give the substituent the least number possible. So you see, going with white gives me 3. Going with greens gives me 2. So the correct numbering here will be the green numbering. So focus on the green numbering. So that's a substituent which happens to be a chlorine, so we'll call it 2-chloro. If it was bromine, it would be bromo, iodine with iodo, fluorine, fluoro. And my sides I have a 2C, and I have a 1C of the sides. So that the name will have the 2, 2, 1. And then overall, I have 7 carbons. The name should have the suffix name hept. There's no double bond, heptane. It's a bicyclic structure. You see down there you have 6 carbon, on top you have like a triangle, a 3 carbon thing, so it's bicyclic. So the final name of this will be will be 2-chloro bicyclo, then 2, 2, 1 heptane. Okay, now that is how you name that. For your information, there are some structures that don't have a carbon in between. So in this case, if I'm to find the number of carbons per side, this is 4 carbons, 1, 2, 3, 4. This is 3 carbons, 1, 2, 3. In between, there's no carbon. You see, it's just a line directly joining it. So the parenthesis for this will be 4.3.0. This kind of structure is called fused bicyclic structure. So in this one, overall, you'll have how many carbons? Let's start from the bridge head. 1, 2, go through the longest side. 3, 4, 5, 6, 7, 8, 9. So the name for this will be bicyclo, brackets 4, 3, 0, 9 carbons, so non-N. And that's how you name such structures. Practice, get better at it.